Okay, so today we're going to learn how to graph trig functions. And in order to do this, for example, graph y equals sine x, on a graph like this where the y-axis is your typical coordinates 1, 2, 3, -1, -2, -3. And if you look over here, the x-axis is in radians. So how do we graph this? Well, the answer to this is we basically unwrap our unit circle. So if you look here, let's list all the key points for theta. Now, let's only use pi/2 increments. Okay, so we have theta 0. Let's move over to here. We have pi/2. This will be pi. Moving around the circle, 3 pi/2 until we are finally back here at 2 pi. So, if you recall, cosine of theta are simply the x values of the coordinates, and sine of theta is the y values. So let's start here. Cosine of 0 is 1. Cosine of pi/2 is 0. Cosine of pi is -1. Down over to here, it's 0. And then back up here to 2 pi. Cosine of 2 pi is 1. Now sine of theta, sine of 0 is 0. It's the y value. And it becomes 1 up here. It's 0 again. And then -1. And finally, we're back home at 0. Okay, so now we have something to work with. We have a table, and let's go ahead and graph sine first. So, sine of 0 is 0. There's a point right there. Sine of pi/2 is 1. Sine of pi is 0. Sine of 3 pi/2 is -1. And sine of 2 pi is 0 again. Okay, and here I'm connecting all these key points with a smooth curve. Think of it like a roller coaster. We want it to be smooth, not very jerky. Now let's graph cosine of x. And if you remember, let's go back to cosine. Cosine of x, when x is 0, or when theta is 0, cosine is 1. Okay, so it goes 0, sorry, it goes 1, 0, -1. Let's go ahead and put that here. 1, 0, -1, and it goes back up to here. Same thing for the negative side, follows the same pattern. Whoops, this goes here, and this slide, oops, that's not going to work. I'll just use the eraser. And there we have it. Let's connect these. And there we go. This is what cosine of x looks like, or cosine of theta. Now I want to take a look at the general graph of a trig function. Okay, it doesn't have to be sine, it can be cosine, sine or cosine. The number, the coefficient of the trig value itself, a, is called the amplitude. It's the absolute value of a, and it is half the distance from the maximum y value to the minimum y value. Okay, so if we go back and we look at our graph here, the maximum y value is 1, the minimum y value is 1. And that makes sense because the coefficient of the trig function, there's no number in front, which means there's an invisible 1. There's one more property I want to look at today, and that is the period. And the period is defined as 2 pi divided by b. It's the length of one complete cycle of the graph. Okay, so whatever the b is, you want to take 2 pi and divide it by b. And b is the coefficient of x. So again, a is the coefficient of the trig function, and b is the coefficient of x or theta or whatever the variable is. So in this example, since the coefficient of x is 1, 2 pi over b, where b equals 1, right, is just 2 pi over 1, which is just 2 pi. And that's why one complete cycle happens in the distance of 2 pi. See, negative 2 pi to 0 is 2 pi, and 0 to 2 pi is 2 pi. That's why we have a complete cycle here. The roller coaster starts here, goes down, and we're done. Start again, down, and we're done. Okay? Same thing with the sine, right? Here we start at 0, we're up, we're down, we're up, and then we're done. Where we ended up. Right? That's a complete cycle. That's called period. What does the 3 in front of the sine x do to the original function? Okay, so again, this is amplitude, and it's basically 3 times the original parent function. 3 times 0 is 0, so we stay there. 3 times 1 is 3. 3 times 0 is 0. 3 times negative 1 is negative 3. And 3 times 0 is 0. So as you can see, the roller coaster now reaches higher heights and lower lows. So you could say that this roller coaster is more exciting now. And that's how we look once we connect the dots. So as you can see, amplitude of 3 means it is higher now. It reaches 3 and reaches negative 3. Now let's take a look at what happens when we have a 2 in front of our x, in front of our theta. So b equals 2, that means 2 pi over b is 2 pi over 2. 2's cancel out, and we're left with pi as our period. In other words, one complete cycle of this roller coaster, which normally occurs between 0 and 2 pi, now occurs between 0 and pi. So what I like to do is put down a vertical guideline. Oops, that didn't show up. Let's try that again. A little thicker. There we go. And there we go there. So basically we're going to squeeze in the complete cycle of the cosine graph into this space here. So the amplitude's not changed. That's still there, right? Still there at 1. But this time, since we start at 0, we're going to end where we start at pi, because that's our new full cycle, 0 to pi. Also, the lowest low at negative 1 happens halfway, right, between 0 and 2 pi, and halfway between 0 and pi is right here at pi over 2. And then at the quarter marks is where it crosses the x-axis. So as you can see, the graph looks like this. So we continue this pattern along here, and it looks just like that. And I already have it finished up over here, and there we have it. So you can also think of it as it increases one valley to 2 valleys within the same amount of time. Okay, instead of 1 valley, it's 2 valleys. Good. Let's take a look at a few Regent-style questions. What is the amplitude of this graph? Well, you might think 2 down to negative 6. So you might say the amplitude is 2 answers, 2 and negative 6, but it's not. Amplitude can only be one answer. And the amplitude, by definition, is half the distance from the highest y value to the lowest y value. That's why there's 8 units between 2 and negative 6, which is divided by 2 is 4. Okay? What is the amplitude? The amplitude is the coefficient of sine. It's 4. The amplitude is the coefficient of sine down here, so it's 1/2. Pretty simple. Number 4, what is the period of the function y equals 5 sine 3x? Well, the period, since b is 3, I'll use the formula 2 pi over b. So 2 pi over 3 is 2/3 pi. What is the period of sine 2x? Well, b equals 2. And we have one just like this. The 2's cancel, and the period is pi. What is the period of the function here? Well, as you can see, there's an invisible 1 in front of the x. And because the denominator is 3, b is actually 1/3. Plug it into the formula, 2 pi over b, 2 pi over 1/3. Keep change, flip. 2 pi times 3 is 6 pi, so therefore the period is 6 pi. What is the period of this equation? Well, because the coefficient of the variable t is pi thirds, b equals pi over 3. So 2 pi over b is 2 pi over 3. Keep change, flip. The pi's cancel out. 3 times 2 is 6. Okay, let's take a look at the Sage and Scribe from today. This will help you with the homework. So we have amplitude is 3, that's easy. And since b is 4, the period is 2 pi over b. 2 pi over 4 becomes pi over 2. So it's interesting because now the period that's normally 2 pi is going to be compressed into pi over 2. So this curve has to be squished into 0 to pi over 2. The amplitude reaches a height of 3 and a depth of -3. So first thing I want to do is put a ceiling here where the highest high can reach and the floor of -3. And I'm going to put some vertical guidelines here too, showing that a full cycle must occur within one of these little rectangular areas. Okay? And since sine of 0 is 0, we're going to start at 0, end at 0. And if you remember, halfway between the full cycle of sine, we're at 0 again. It's the quarter mark where we reach 1. And instead of 1, the amplitude is 3, so we're up here. And here at the 3/4 mark, we reach -3. So to tie this all together, it's kind of a crazy looking graph, but it kind of looks like this. There we go. And here's the completed version with some neater handwriting. So as you can see, we fit 1, 2, 3, 4 complete cycles in the space that we would have normally fit 1. Okay? Let's look at one last example. Okay, in this example, the amplitude is 3 again, but this time the period is 1/4, right? Because we have an invisible 1 here, and the 4 is in the denominator, so the b is 1/4. So because b is 1/4, we have to do a little keep change flip action. And as you can see, 2 pi times 4 is 8 pi. So in order to make all this fit, I'm going to draw my ceiling and my floor. Can't go beyond there. And 8 pi is now my new full cycle. This is the period, 8 pi. So I know that when I sketch my cosine, normally cosine of 0 is 1. Now we're going to start here at 3. And normally we end at 1, but we're going to end at 3 again. And the lowest low is at right in the middle at -3, right? 4 pi, so it's -3. So I know it's going to be like this U-shaped kind of curve, not quite a parabola. But at the quarter marks, which is 2 pi, if halfway is 4 pi and the quarter is 2 pi, we're going to cross through the x-axis, and also at 6 pi. So once we put that together, it kind of looks like this. And here's the completed picture, completed graph. And there we have it. This actually needs to go further over here, but you get the picture. Okay? And that is today's lesson. Best of luck to you.